Hello everyone. This video is a continuation of a section on percents and percent word problems. So in this video we will talk about converting word problems into either an equation or a proportion, or maybe you have a different method for translating a word problem into a mathematical format. And then we will talk about solving a variety of these word problems. So first of all, how do we turn a statement like 50% of 10 is 5 into a calculation? So it's close to a calculation. We do have numbers here and it's a single statement, but we have these words of and is. So what do we do with these? Well, think about how these numbers are related. 50%, 10, 5. And you may be familiar enough with percents to know what to do with these things, but notice that 5 is half of 10. 50%, if you write that as a decimal, that's 0.5. Right, so if you're trying to figure out how to combine these numbers and have one of them be an answer, if you can only use operations like multiplying, dividing, adding, subtracting, and then also an equal sign, well, notice if you multiply 0.5 times 10, that equals 5. All right, so you may recall to take a percentage of something, you multiply whatever that number is by the percent. All right, so you can make yourself a little key here if you want. In percent problems, the word of means multiply, and then the word is indicates an answer or indicates an equal sign. The two things on either side should be equal. All right, another option. Maybe you learned proportions rather than equations. So there are other ways to write something like 0.5 times 10 equals 5. All right. You may notice that 50%, if you write that as a fraction, that's 50 over 100. And you may notice that that's the same thing as if you took 5 and divide it by 10. Both of those are equal to 1/2, or they are equal to each other. Right? So what we have here is a proportion, and a proportion is just two ratios or fractions which are equal, but they just look a little bit different. Right? And both of these are the exact same thing. They're just manipulated a little bit. They look a little bit different. All right? For example, this equation, if I write 0.5 as a fraction instead, that would be 5/10. Okay, I could divide by 10 to move it to the other side. And then if I multiply the left-hand side by 10, it's like putting a 0 on each of those, and then I get the same proportion. All right, so maybe one of those equations looks a little bit easier to you, either kind of a linear equation, or I guess I shouldn't use the word linear, that seems to imply like an x or something, but like a horizontal side-to-side equation, or maybe you like a proportion. Okay, so let's talk about using either equations or proportions to solve word problems. According to MinorityNurse.com, just 5.8% of all registered nurses in the U.S. are men. The average hospital in 2012 had 335 registered nurses. How many of them would likely be male? Okay, so in these word problems, we need to write a proportion or an equation. So your proportion will always look like a percent over the number 100. So in our last example we had 50. 50 was the percent. Okay. And that will equal some sort of a portion or a part over a whole. Now watch out, because the portion isn't necessarily smaller than the whole, especially if we were talking about a percent like 300%, something bigger than 100. Then our portion, we would actually have more than a whole. We might have 2 or 3 or 4 of something. Okay, we have a portion over a whole. You may have also learned that whatever number goes in the numerator goes with the word of, and then the whatever number goes with the word is goes in the denominator. Okay, so percent over 100 equals, oh, I'm sorry, actually I think I switched those. Is the numerator, of is the denominator. Okay, so if you look back at the previous example, all right, we had 50%, right, so here's the percent, 50. Okay, the number that goes with is was 5, and that is in the numerator. And then the number that went with of is in the denominator, the 10. Alright, now if you write an equation, we do the same thing, it just looks slightly different. You do the percent, but you write it as a decimal instead of as a fraction. Percent of something, whatever goes with the word of. Okay, because of means multiply. Is means equals. And then whatever numbers with is goes on the other side. Alright, and then we have percent of a whole. So this number, the second number, is going to be the whole. And then over on the right we'll have the part. So let's try to write both of these, a proportion and an equation, for this problem. Well, if we start with the proportion, we need the percent, that's 5.8%. Alright, over 100. And then we need the portion on the top, or if there was the word is, if we had like a single statement like the previous question, that would go in the numerator. Well, we're talking about an average hospital with 335 nurses. How many would likely be male? All right, well, if we rephrase this a little bit, this is kind of like asking how many of them, how many of the 335, or how many out of 335 would be male. So the 335 is the total or the portion, or I'm sorry, the total or the whole. So that's the number that goes in the denominator. That represents the total number of nurses at that average hospital. And then what we're trying to solve for is the portion, the part, how many of them would be male. We don't know, so you use a variable, something like x. All right. Now on the right over here, let's try to write an equation. Same thing, we have a percent, 5.8, but now we are going to write this as a decimal, so you need to move the decimal point 2 places to the left and write that as 0.058. Then we need to multiply that by the whole, so 5.8% of the total number of nurses, 335, is how many? And we don't know, so you use a variable x. Now, some people don't like to really write this equation. They'll just say, okay, well, I know what I need to do here to solve. I just need to multiply 0.058 times 335. Okay? And so notice it's really just the left side of the equation that we've written. And then instead of writing x on the right, they just solve and get the answer for whatever x is. All right, and that's fine too. There will be times when you have a variable on the left, so it's not really as clear what the operation is that you're supposed to do. Some of them will be division, but if it's clear to you what arithmetic you are supposed to do, then you could just jump to doing that. Okay, I think you know how to solve an equation like this, but let's review how to solve a proportion. Probably, I guess the easiest way to remember is to cross multiply. So you would end up with 5.8 times 335 equals, and then on the other side you have the other part of that, the cross multiplying, 100 times x. And then to solve, you divide by 100. Okay, let me just pause there and clean this up a little bit. Alright, so I've just recopied these. On the left hand side, this is your proportion. Okay, so we could kind of just simplify that using a calculator to see what x is. Okay, you definitely want to keep a calculator handy for this section. So 5.8 times 335 divided by 100 is 19.43. And then on the right, if you multiply, you do get the same thing. Alright, so notice that the differences in the proportion in the equation, just that writing the 5.8 either as a percent, right, or in decimal form, those do get worked out when you get to this step, the dividing by 100. There's that extra step in the proportion that you didn't have to do over here in the equation. It's already been done. And then finally, we just want to interpret the answer. So you have to decide, should we leave that answer for x, or should we possibly round? Well, this question is asking how many out of the nurses would be male. So since we're talking about people, it makes sense to round to the nearest whole number. So we can say about 19. And we'll stick with the normal rules for rounding. So if you're rounding to the nearest whole number, then you look at the place to the right. If it's 5 or more, round up. Okay, if that had been a 5, I would have made this about 20. And if it's 4 or smaller, then round down. So we rounded down to 19. Alright, let's look at another one. Finding a percent from a discount. In 2012, 22 out of 50 states had a population of 5 million or higher. What percent is that? Okay, so let's try to set up either a proportion or an equation, and I'll try to work out both examples, but you can just take your pick, one or the other, whichever one you prefer. Alright, so if I do a proportion, I need a percent over 100. Well, I'm solving for the percent. I don't know what that is, so I'll use an x. And then on the right, I need a portion and a whole. Okay, so I'm being asked what percent of the states had this population of 5 million or higher. Okay, well that was 22 of those states. So what percent is that? What percent is the 22 out of the 50? So the 22 is the portion out of 50, and 50 is the total. All right, notice that 50 goes with the word of, so that's another confirmation that that's in the denominator. And then if I write an equation for this, I have percent as a decimal, I don't know what that is, so just use an x, times a total. So in other words, what percent of 50 is 22? Alright, so hopefully one of those two options works for you. If you like the arithmetic method, then you may realize that to find a percent, if you have the portion and the total, then you could just do 22 divided by 50 and then just convert to a percent. Alright, so we'll try all three of these methods. Proportion on the left here, you would cross multiply. So you would get 50x equals 22 times 100, and then divide by 50, and that's 44. Okay, now remember, proportions give you percents, not decimals. So right away we can just say if x is 44, this is 44%. Just put the percent symbol on it. Okay, if you do the arithmetic, 22 divided by 50, that gives you a decimal. So if you do it that way, then you'll need to remember to convert to a percent. Move your decimal to the right. And then same thing for the equation. Divide both sides by 50. And then you're getting the same thing as the arithmetic. So the arithmetic is really just skipping the setup for that equation, but you're still doing the same operations. Okay, so you'll get a decimal, which you then convert to a percent. Let's try example 7. Find a whole based on a percentage. A medium-sized company reported that it had to cut its workforce back to 70% of what it was last year. If it has 63 workers now, how many did it have a year ago? Okay, so they cut it back to 70% of what it was last year. So let's try an equation for this. We know the percentage, 70%, and let's make that a decimal. So 0.7. So we need 0.7 of something is something else. Well, it's 70% of what it was last year. Do we know how many people they had last year? Well, no, we don't. That's what we're trying to solve for. So that part is the variable in the equation. Okay, and then they cut back to 70% of what it was last year, and that's what they currently have. Okay, so when they did that, 70% of last year's total number of workers is the number of workers they have now, 63. All right, now if you write a proportion, we have 70 over 100, and then what we need to decide is, do we have, we have this other number 63, is that the part or is that the whole? All right, well, 70 is a portion of 100, or the smaller amount. Okay, and then the workforce was cut back. So 63 is the current number, it's the smaller number because the workforce was cut back. So that should go in the numerator. All right, and then what we need to know is what was the total from last year, the higher amount. Okay, so then you can either cross multiply to solve that one, all right, or solve the equation. And let's see what you end up with. Let me get a calculator. Let's see. If you solve the equation, you get x equals 90. Okay, and then same thing for the proportion. 70x equals 6,300 divided by 70, and you get x equals 90. All right. Now, if you just look back at the problem, see if this makes sense. Okay, so we know that the workers last year, there should have been more of them since there was a cut back to the 63. All right, so if you ended up with something that was actually smaller, then you would know that you probably had, the 63 and the x in the wrong place. All right, how about sales tax? I think you're probably more familiar with examples like this. A lot of people, make this calculation in everyday life. The sales tax in Allegheny County, Pennsylvania is 7%. What is the tax on a calculator that costs $89.95? What is the total amount paid? All right, so let's find the tax first. We need to know what is 7% of 89.95. Okay, so as an equation, we don't know the answer, we don't know the is part of this, the portion. Tax is the portion. I do know the percentage, I'll make that a decimal, 0.07. And then I do know the total, what I'm taking a percentage of, 89.95. Okay, so calculate that. Let's see. 7% of 89.95. Okay, I'm getting 6.2965. And this would be an example where you actually would want to round. Since we're talking about sales tax, it would make sense to round to the nearest cent. Okay, so that's this place. So look to the number to the right, it's a 6. So I should round the 9 up to a 10, and that's going to carry over and make this $6.30. Okay, so tax is about $6.30. And then the total amount paid, well, then you just need to add the tax on to $89.95. $89.95. Okay, plus $6.30. And total amount paid, $96.25. All right, now there's a math note in your textbook that I've included here. Some of you may be familiar with a shortcut to finding the total amount. If you don't necessarily need to know exactly what the sales tax is, what you could do instead is multiply by, instead of 7%, multiply by 107, 1.07 times the amount, and then that gives you the total amount. All right, so what you're doing here is the 1 represents 100%, and the 0.07 represents 7%, so you're finding 100% of the original amount, and then you're finding the sales tax amount, the 7%, and then you're just adding those two together. All right, how about calculating cost of a sale from commission? A real estate agent receives a 7% commission on all home sales. How expensive was a home if she received a commission of $5,775? All right, so what do we know? We know the percentage, and then we need to know if this commission is the part or the whole. Well, anything like sales tax or commission or a discount or a price increase, all of those are going to be portions or percentages of total amounts. Okay, so that's going to be our part or our portion. All right, so that is the 7%. 7% of something. Okay, so as a proportion, we would have 7 over 100 equals, and then I know the part, 5,775. And then what I don't know is the total, the 100% of the home's price. Okay, as an equation, I know that 7% of however much the house cost equals $5,775. Right? Now, if you're doing the arithmetic method, notice what you're doing to solve this equation. The next step is to divide by 0.07. Okay, so you may like the process, or you may know already that to go back from a part to a whole, you take the part and divide by the percentage, and then that gives you the whole. All right, now proportion, cross multiplying, 7x equals 0.577500, and then divide by 7. And then both of those should give you the same thing. And let's see, I'm getting x equals 82,500. It's a pretty cheap house. All right, what about percent increases or decreases? Well, let's say you know the amount of an increase or a decrease. So let's say that you have a coupon for $10 off of $50 or more. That's an amount in dollars of an increase or decrease. And then to find the percent of the increase or decrease, you just make a fraction of that amount of the increase or decrease over the original amount, and then just change the fraction to a percent. Alright, so let's try it. A large latte at the Caffeine Connection sells at a regular price of $3.50. Today it is on sale for $3. Find the percent decrease in the price. Well, first I need to know the amount of the decrease. So this dropped by 50 cents. And then I just make a fraction, the amount of the decrease, over the original amount. So here's the regular price, $3.50. Okay, and then divide. Alright, that's 0.14287 ... It's a repeating decimal. In this case, let's just go ahead and round. Okay, and then we want to convert to a percent. So move the decimal 2 places to the right. And that's about 14%. Alright, so it's kind of an odd percentage discount to give, so maybe they did say something like, today we're having a sale, get 50 cents off your order with this coupon or something like that. Alright, how about a population increase? The population of the town of Oak Creek in 2012 was 23,258. In 2013, the population was 23,632, so it increased. Find the percent increase. So first of all, let's find the amount of the increase. Well, what we're really asking is for the difference between these two numbers, the two populations. So if you subtract, that should give you the amount of the increase. And let's see, that would be 374. Okay, and then we just make a fraction. The amount of the increase over the original amount, so that would be the 2012 population, 23,258. Now that's a common mistake, is to put the wrong number in the denominator there, so always make sure that it's the original or the old amount. Alright, and then you want to divide so that we can convert to a decimal and then to a percent. 0.16080, etc., etc. Move your decimal, and then since it's kind of a bulky, non-terminating decimal to work with, let's go ahead and round. So you could say that this is about 1.6%. That would be fairly accurate. You could even say 2%, something like that. And finally, let's end on an example about recognizing misuse of percents in advertising. Alright, so a kind of a common misconception is if you have two coupons, for example, here we've got 25% and 10%. A lot of people think that if you just add those together that you're getting a 35% discount. Well, let's check and see if that's actually the case or not. A department store advertised that the merchandise was reduced 25%, and then an additional 10% would be given to the first 200 people who entered the store. All right, so let's try this out. And we don't really have a purchase price for an item in the store, so let's just choose one. And let's go with $100. That one's, a nice rounded number to work with. Okay, so let's say you're buying a $100 item. So first of all, it was reduced 25%. Okay, so I think you probably know what that is, but let's work this out just in case. Let's find 25% of $100, and that's $25. So reducing it 25% means subtract that amount. And so now the item is down to $75. Okay, and then an additional 10%. So anytime you have an additional discount, that's your clue that you apply one discount first before going on to the other. So that's why we're doing it this way and not just adding the percents together to take 35%. Okay, so we did the 25% first. Now we'll do the 10%. So we want to find 10% of 75, which is $7.50. And then we want to apply that discount. So from 75, subtract $7.50. Now you're down to $67.50. All right, well, what percent discount was that? Well, we know the total amount of the discount. I can find that by subtracting 100 minus 67.50, and that's a $32.50 discount. Okay, and using the formula from before, okay, the amount of decrease divided by the original amount should give us the percent discount. So we have the amount of the decrease, $32.50, divided by the original amount, 100. Okay, and then, you're going to just move the decimal back again to make a percent. So that's actually a 32.5% discount. So it's not quite as good as if you had just added those two discounts together. All right, that's it for this section. So there are additional practice problems in the textbook and some additional examples, and try this one exercises if you need them.